So usually you will probably have heard about the TLS or terrestrial laser scanners, which are fixed systems. These systems, on the contrary, are they can move and they track movement as well as GPS signal. So in the end, you get like a much more time efficient scan, because TLS you have to move the system and then you have to process it and then I guess so stitch together all the point clouds. But this you can get a pretty nice cover of the forest with a single scan. So this is the Kudan system. It uses an Auster LiDAR sensor. This can acquire up to, I think, 2 million points per second. 5 million points per second, that's even more, okay. So much more data than you would get from probably a drone or unmanned aerial laser scanner, right? And the difference is you will get data from within the forest, so under canopy. And this is a very interesting technology to characterize how the stems look like and sort of get like a, I guess, a forest inventory automatically, or at least that's what we are trying. It becomes a bit difficult in first innings. If the forest is too dense, then you get very messy point clouds. That's very difficult to process. But in forests like this, and after a first inning, then you get very good data. So what I'm going to do now is do a very short scan around, and I will show you what the point cloud looks like while I am scanning. And as I said, it tracks the movement, so you can see yourself in sort of like this 3D space as this 3D point cloud is being generated.
So if you want, we could create a digital twin of you.
Yes, if you stand still, you will probably see yourself there, even probably your face. And once I'm finished with the scan, we can process the point cloud and you can take a look at it. So
the other good thing about this scan is that you can detach this from
Yeah.
here, so you can put it in a vehicle.
yes,
In our case, we put it in a harvesting equipment. So yeah, it has a 5-meter cable. So
that's something we did in the past actually. You sort of attach this to whatever place you want, and you can even get this unit like this, and then you can attach it wherever you want. Can be a machine, can be whatever. Yeah, it's 90 degrees field of view.
Yeah.
So if it's in this position, you will be seeing something like this, upwards and downwards, and it has a 360 degrees of view horizontal. So I'm now connected to the computer via just hotspot, so Wi-Fi technology, and I can see here the screen of the system. So can you help me? Yes.
Yep.
Let's get it. So how? This way.
another important thing about this scanner is that you need to know how to walk the forest. Sometimes the best way is to do spirals. So you start from the middle and you start doing spirals, walking in a spiral fashion. That's the best way because you cover all the trees from all the angles. With this scanner, you have to do what is called, you have to close the loop. So you have to come back to the same spot where you started. It's not a requirement now, I think, but I think it's better to come back to the same to the same spot. With this system, you get a map. And then once you have the map, you can run other algorithms to estimate diameters at different height. You can calculate the height, crown size, things like that.
Yes.
But with this, you capture raw data first, and then with the computer and the software, you get a map, produced by the SLAM algorithms. And then you can do whatever. Yeah, so we have seen a demonstration of what is called mobile LiDAR. So with that scanner, you can walk the forest and get a very good description of the trees in the forest. So that's something we are doing in our projects. In this particular project, we are using that data to optimize tree selection during the thinning. And to do that task, we need to have very good data of the trees. When I say good data, I mean curvature, height, diameters, and biodiversity, and also ground conditions. So Borja is the PhD student in charge of that research. So I don't know, Borja, you want to say something?
Yeah, with this kind of sensors, we can get a kind of data that we don't get with drones, for example, because drones only fly above canopy. And you can fly under, but it's not normal. So we get, as Mauricio said, much better data from the stems with much more accuracy. So that's important part for our purpose. And yeah, we get it with much more efficiency than with TLS systems, for
Yeah.
example.
But also all this, the data can be combined. So, for example, we can use drone lidar data combined with ground-based lidar data. So, and that would be perfect. We can do fusion and combine the data and get a much better information about the trees in the forest.